Good morning. We're now going to start chapter 29, the sun. And I want you to open your book then to page 758. 758. Where we're going to do words 1 through 11 this morning, and then look at some diagrams that I have. So have your book open to 758, please. Thank you very much. The first word there is spectrum. And you've had this before. Spectrum, for spectri, neuter, second appearance from an image. Former image. A band of the various colors of light. A band of colors formed when light is passed through a prism, each refracted according to its own. There's a lovely diagram of that on page 555 in case you forgot. But it starts with the colors. Remember, you have on the one side you have the ultraviolet, and then it goes from violet to blue, blue to green, green to yellow, yellow to orange, orange to red, and then infrared. So you've had that many times. Now here's a variation of that. Bright line spectrum, Middle English bright, shining, line, merging, plus spectrum. Each element produces a series of thin colored lines spaced at uneven intervals. Each element produces its own bright line spectrum, as unique as a set of fingerprints. And you can see on page 15. And each one, so if we know that hydrogen burns one color, helium another color, so, and all so forth. Each element has that. Okay? We've already done nuclear fusion and nuclear fission. Fission is on Earth. We do that. And we want to do the nuclear fusion. We don't know how to do that. The process by which the nuclei of small atoms combine to form a new, more massive nucleus, and the process releases energy. And where does that happen? It happens on the sun. And we're trying to figure out how to do that, and then we might have more energy that is less polluting than our carbon-based energies. And Einstein had this formula: energy equals mass times c squared, which is the energy equals the mass of an object times the velocity of light squared. Okay, mass times velocity of light. An equation of Einstein that can be used to calculate the amount of energy produced from a given amount of matter. Could we move up, please, on this thing? Now, this is word 5. If you go back to your diagram in your book, it's on page 578, and this is the diagram that I gave you on my notes, but this one happens to be in color. I don't know how you got it in color, but I'm very happy you did. Core, cordis, feminine third, heart, or cornu, neuter horn. I'm not sure where the chord, what root it is, so I put both down in Latin. The sun's center is about 15 million degrees centigrade, makes up about 10% of the sun's diameter. And then you have all these zones. So the first one is a radiative zone from radiatio, radiationis, feminine third, radiation, shining Greek, zone 1 belt. Okay? The zone of the sun's interior that is between the core and the convective zone, in which energy moves by radiation all the way out. The temperature here is about 2 million degrees to about 7 million degrees. And if you look at the core, you have the radiative zone, then you have the convective zone, and then you have the photosphere. That's where the light comes from, and that goes all the way out into space. And between that you have the chromosphere, and he has a few more prominences and flares, which we'll talk about a little later. And the corona. Okay, now, next word is the convective zone, with a lovely picture again. the region of the sun's interior that is between the radiative zone and the photosphere. So the convective between the radiative zone and the photosphere, okay? And in which energy is carried upward by convection. You had that, remember, going circulating up. You have a convective cell, up and down. Hot things go up, cooler things go down. The temperature is about 2 million degrees centigrade. Photosphere, Greek photos, light, sphera, spherae, feminine first, globe. You've had those words before. The innermost layer of the solar's atmosphere, inner layer of the atmosphere, not the inner layer of the sun, inner layer of the atmosphere. Okay, of the solar atmosphere, the visible surface of the sun which produces visible light. Light sphere, some books call it. So the temperature here is about 6,000 degrees centigrade. And you look at the next one words, please. We go up to word 11. So chromosphere, Greek chromosphere again. The thin layer of the sun that is just above the photosphere, therefore it's part of the atmosphere, and that glows a reddish color during eclipses. And we saw that when you had that wonderful corona and circle around the sun when you had a ring kind of eclipse. So the corona then is the outermost layer of the sun atmosphere, crown. The temperature here is about 1 million degrees. So if you go out then, so you have the photosphere, the inner layer, and then you have the, after that you have the chromosphere, and after that you have the corona, the outermost layer, okay? Word 11, I think we go up to word 11 today. Solar wind. Solaris, you already had solari pertaining to the sun. Ventus, vente, masculine second. Wind, we talked about wind many, many times. The electrical charge atomic particles that stream out into space through the holes in the sun's corona. Okay, and that's caused by flares and prominences also. They all go. And we had that before, but we're stopping today with word 11. Don't forget to do your assignment and questions on page 760. And I hope to see you tomorrow. Well, it's not tomorrow. It's really not until on Monday. So thank you again, and study hard, stay well, and keep up on earth science. I love it. I hope you love it too.